section 4.9. It's called Roots and Zeros. It's on page 293. It starts out kind of a concept that we had talked about earlier, is if we have a polynomial function, okay? P of x is a polynomial function that is in this form, plus dot 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 plus a sub 1 x sub plus a sub 0. If it's in this form, this is any polynomial of one variable. You've seen them a lot, like 3x squared plus 9x plus 4e. Those are polynomial equations. These are polynomial functions. Okay, some things are true. Let's take a look on page 293. The first one is, and they use bullets, but c is a 0 of p of x. So there's some constant that is a 0 of p of x. Okay. Now, if c is a 0, then that's where that graph touches the x-axis. Correct?
Where does c come in?
We just made it up.
Okay.
I mean, it's any number.
Okay.
Okay. We could have called it x. We could have called it y. We just said, hey, they actually use c for, it stands for a constant. Okay? But they're saying that, Izzy, that c is a 0 of p of x. We're just saying it. Okay? The next thing is that c is a root or solution. Okay? C is a root or solution of p of x equals 0. So if you set the function equal to 0 and you factored it, then c is a root or solution of it if you solve for it. So what we've said now is that c is where the graph touches the x-axis. Let's put that down. Where the graph touches x-axis, right? And c then is a root or solution of the equation p of x equals 0. Now, if all this is the case, then x minus c is a, I'm going to put in parentheses, is a factor of p of x. In other words, this is a factor that we just witnessed that last problem, remember? When we found the solutions, we had to work our way back. Okay? All right? And then the last one, if c is a real number, now it has to be real, it can't be imaginary. Do you understand that? It can't be imaginary. Then C0 is an intercept, an x-intercept. Of the graph. Of p of x. Okay? So let's go through it again. All four of these are true. If c is a 0 of p of x, then c is a solution or root of p of x equals 0. And then x minus c is a factor of this. And then if c is a real number, then c0 is an x-intercept of the graph, which is what we set up here, right? Okay? Now they show this in that example. All right? It says, consider the polynomial p of x equals x to the 4th plus 2x cubed minus 7x squared minus 8x plus 12. Notice the zeros are what? Where it touches the x-axis. Look at it. Looks like a -3, a -2, 1, and 2, correct?
Yeah.
All right, there's 4 of them. Did you notice that the 4 corresponds to the exponent of the leading coefficient? Right? All right, then the roots are a -3, a -2, 1, and 2. Do you understand that it looks like we're repeating ourselves, but one is actually called the zeros, the other ones are called the roots. So then the factors, look at the factors. They are x plus 3, x plus 2, x minus 1, and x minus 2. You see how they become binomials?
Yeah.
And then finally the x-intercepts are written as those numbers at 0. Does that make sense? What's wrong, Maya?
Yeah.
Okay, all right. So there is what we call the fundamental theorem of algebra. It says every polynomial with the equation with every polynomial equation with degree greater than 0 has at least one root in the area of complex numbers. Guys, every polynomial has at least one in the root and is a member of the complex numbers. Okay, that means it can be imaginary or not, but there's at least one root. Yes, ma'am.
Where did they get -3 out of that?
Do you see in the graph between -4 and -2, there's a line that touches the
Yeah.
x-axis? That's a -3. They just didn't label it.
So they got the zeros from the graph?
Yes.
Oh, okay.
Yes, they got the zeros from the graph.
Okay.
And you could have factored it, just like we did that one
Mhm.
before. You could have factored and got the zeros, because those
Okay.
all came out, didn't they, even?
Yeah.
Right? Okay. So on the next page is the first example of the types of problems you're gonna do. It says solve each equation, state the number and type of roots. So we're gonna solve an equation and state the number and type of roots. So how many roots are there and what kind of nature are they? Alright, number one, we have x squared plus 6x plus 9. It says state the number and types of roots. Okay, let's take a look at that. If it's equal to 0, you notice that you can factor this, correct? Alright. So we're gonna factor it as two binomials equal 0. So x and x, and what would it be if I factored it?
Plus 3.
Okay, so all I have to do is set one of them equal to 0, and I get x equals. Alright, so it says state the number of roots, and the type of roots. So we have one root, and it is a real root, right? Now they say a real double root, I believe, since it's repeated.
Okay.
So this is a real double root. Do you understand why it's a double root?
Because x plus 3, x plus 3.
X plus 3 times x plus 3. Okay. All right, let's take a look at the second one.
So then the one real double root is the answer.
What's that?
So then the one real root is the root thing.
Yes. Yes. We have one root, but it's a double root.
Okay.
Okay, so let's take a look at this one. First thing we're gonna do is factor out an x. Okay? You think it's a perfect cube, but did you notice that this one has an x also?
Mm-hmm.
So we need to factor that x out. Correct?
Yep.
Alright. So now, let's factor this. We can't. You can't factor it, sorry. Got excited. If this was a subtraction sign, we could factor it, right? But it can't. So we set them both equal to 0. The first one's easy, x equals 0. The second one, not so easy. And so I moved the 25 over the other side.
X equals a -5.
On that, looks like to me if I take the square root of both sides, I get x equals, remember?
5i.
Plus or minus 5i, right. Okay, so what we get is we get one real root. One real root. You understand that? You understand what real means,
Mm-hmm.
right? It's not imaginary. And then we get two, don't forget, there's two of them here, imaginary roots. That make sense?
So is I 1?
I is not one. I is
It's
the square root of a negative one, remember?
Because x squared.
What is it like? Is it one of the roots? Is what I mean.
No. 5i is one of the roots, and a negative 5i is one of the roots.
Oh, okay. Is the plus or minus?
Correct? All right. Any questions? Okay, so there's this way to tell whether the roots are positive, are negative, or imaginary. Okay? It was devised by a Frenchman named René Descartes. Now you might remember René Descartes because he was the one that came up with the Cartesian plane. It was named after him. He did it when he was 9 years old, around 9 years old. That's pretty good, right? But he also came up with the rule of signs. By the way, he was a philosopher too. He's famous for saying, "I think, therefore I am." Okay. Back then, everybody wanted to prove that they existed, and so he was like, "No, I don't know why," but that was the time. All right, so Rene Descartes, I'm gonna read this to you and then I'm gonna explain it to you, because I can read it to you 5 times, it's kind of hilarious. She'll go to sleep, you won't. Some of you will panic, but this is what it says. If p of x is a polynomial function with real coefficients, then the number of positive real zeros of p of x is the same as the number of changes in sign of the coefficient of the terms, or is less this by an even number, and the number of negative real zeros of p of x is the same as the number of changes in signs of the coefficients of the terms of p of a negative x, or is less this by an even number. Okay, if it sounded like a foreign language, you're fine, okay? Okay, when I first started teaching this, I had to go over it like 9 times to get what they were talking about. But this is, I'm going to show you. And let me look at example 2. This is a great way of showing you how this works. Okay, remember that we're trying to find the number of positive, the number of negatives, and the number of imaginary. By the way, I do it differently than the book. The book doesn't care about imaginary, I do. Okay? It says state the possible number of real zeros, negative zeros, and imaginary zeros of f of x equals x to the 6th plus 3x to the 5th minus 4x to the 4th minus 6x cubed plus x squared minus 8x plus 5. By the way, I lied. This book does care about imaginary. I just remembered that when I read it. Okay, so we got to do f of x equals x to the 6th plus 3x to the 5th minus 4x to the 4th minus 6x cubed plus x squared minus 8x plus 5. Okay, now keep in mind, guys, that it's not like synthetic division, and if you skip one, you put in a 0. You don't do that here. And my advice to you is to keep one sign between the coefficients. So don't say plus and negative. That's what I'm asking you. Okay, so what we look for is we look for sign changes.
Okay.
What's the sign in front of this one?
Plus.
Plus. It's plus. There's nothing there. And since we're lazy Americans, we assume that it's plus, correct? So this is that a sign change from a plus to a plus?
No.
That is no. So we're going to put a big fat N for no. What about that one?
Yes.
That plus, that minus is a yes. So put a Y. What about that one? No. What about this one? And what about this one? What about this one?
Yes.
Okay. All right. So now we count the yays. All right. There is 1, 2, 3, 4. Now, so the number of positive roots are 4 or an even number less than that. 2 or 0. 4 to a 0. Now, let's say I would have got 5 y's. Then my options would have been 5, 3, or 1. You understand it? So if it's 10, it'd be 10, 8, 6, 4, 2, and 0.
So you always skip one? in
Well,
between?
you go an even difference down.
Oh, okay.
Oh, okay.
Right?
I got
So if it's an odd number, it's odd numbers all the way down to 1. If it's an even number, it's even numbers all the way down to 0. Does that make sense? Yep.
Yeah.
Okay, so that tells us that these are possibilities. We either have 4 positive roots, we have 2 positive roots, we have 0 positive roots. Are you okay?
Yes.
All right. Now what we do is we find f of a negative x. And now we're looking for what kind of roots do you think? Positive or negative?
Negative.
We're looking for negative, the number of negative. All right, so what we do is for every x, we put in a negative x.
Okay.
So I substitute in there a negative x for every x. Okay, now I go through. What happens when you take a negative x and you raise it to an even power?
It's
It becomes positive. So this actually becomes x to the 6th. So I have to simplify this. But the next one, that is negative, isn't it?
yeah.
So this actually becomes a negative 3x to the 5th. Izzy, do you understand that? Okay?
Yeah, okay.
Okay. Now take a look at this. This is positive, correct?
Yeah.
But there's a subtraction sign there. It stays there. I didn't change it because it wasn't negative. I go to the next one. This is negative. correct?
Yep.
Mhm.
And so I have a negative of a negative, which is a positive.
Positive.
There you go. This is positive,
Mhm.
isn't it?
Yep.
Notice I'm putting one sign in between. Don't do plus a negative, because that'll throw you off. And this is a negative of a negative, which is a positive. And then finally the 5 is positive. You can't change that. Okay? Now let's go through our sign changes. Same thing. We do the same thing here. Is that a sign change?
Yes.
Is this one?
No.
Nope.
Is this one?
Mhm.
Is this one?
No.
Is this one? Is this one? No. Alright, so we have a possibility of 2 or 0.
So you count the Y's.
You all
All
just
the
count the
Ys.
Y's. Yeah, even if it's negative, you count the Y's. We don't like to because we think that should be a no, right?
Yeah.
Okay. Alright. So I create a chart. This is Renee's chart. And the chart says that I have every type of combo possible. Okay, now I'm gonna tell you something. Imaginary numbers come in pairs.
Okay.
So there's either 2 of them, there's 4 of them, there's 6 of them, there's 8 of them, or so on. You understand? Okay, so I start with the 4. And I go, it's combo with 4 and 2. Alright? Correct? Alright. How many is that? Do you see I'm at 4, 2. How many is that? How many roots? If I had 4 positive and 2 roots, how many total roots?
6.
6. What's the number of roots I can have in this?
Six.
6. So what does that leave for me for imaginary?
0.
0. Alright, let me say that again. Okay. If there are 4 positive and 2 negative, that's a total of 6. I've got all my roots, there can't be any imaginary.
Okay.
You got that?
Yep.
You understand it?
Yes.
Maybe the next one. If not, stop. Alright. Okay, the next one is, I do stay with 4 and I go to 0. Okay, Maya? So 4, 0. You understand it?
Why?
Okay, because I do every possible combination.
Oh, okay.
Okay, every possible. Maya, do you understand it?
Yeah.
Okay, so 4 to 0. How many total roots are there?
4.
And down here. But how many total should I have?
6.
So what does that leave me for
2.
imaginary?
2.
2. You understand? Okay, so now I'm done with the 4 because I've done it with both of them.
Mhm.
So I cross out the 4, whatever you want to do, and move to the 2. Okay, so now I take 2 with 2. Sophia, if I have 2 positive and 2 negatives, what does that leave me for imaginary?
2.
2. 2, 2, and 2 is 6, correct? These should all add up to 6, right, when I'm done?
Yep.
All right. You're getting it, Maya?
Yeah.
All right. So now, I've done 2 with 2, I do 2 with 0. What's that leave me here?
4.
All right, now I'm done with 2. Now let's go to 0. If there are 0 positive and 2 negative, how many imaginary?
4.
Okay. And finally,
0.
if there are 0 positive and 0 negative, how many imaginary?
6.
And that's all the different combinations you can have for Descartes' rule of signs.
Oh.
Okay? Now this is just a possibility. Okay? But it's something you need to know. Okay? Questions so far? How much time do I have?
Like
5
5 minutes.
5 minutes. Okay. And I have you for nothing tomorrow,
Correct.
which is Thursday.
Yep.
Yes.
All right. Okay, so I want you to work on some of these. I think that will get you to 32. And you can actually find all the zeros because we've done that before. So let me go ahead and assign it so we're not rushed. And then I'll come back on Friday and teach the rest of it. Okay, and we'll answer your questions, okay? Yes, there is. Page 298, numbers 17 through 35, comma, 39 through 41, that's comma, and then 45. Okay.
Due Monday?
That is due Monday, yes.